What really happens in your home when the grid goes out? And more importantly, how can your home stay powered during a grid outage? If you have a solar system on your roof, let's look at how that works. In this example, I'm not talking about an off-grid system. We're looking at a grid-connected system. The sun is shining, and as expected, your system is converting that sunlight into electricity. That electricity is used to service your loads, meaning the solar-generated electricity is running your lights, your TV, your air conditioner, etc. When it produces more electricity than your home needs, the excess electricity is exported to the grid to be used elsewhere. Now, there is what is called the solar paradox. This happens when you have a grid outage, and going against what you might expect, your solar system shuts down. Now you have solar installed, but it's not working during the time you need the power the most, during a power outage. This is often a very unpleasant wake-up call for solar-only homeowners. So why doesn't your solar work during a power outage? There's actually a very valid reason. It's because of safety. When you're experiencing a power outage, your local utility jumps into action to try to fix the problem as quickly as they can. This may include line workers fixing a downed power line, technicians repairing a blown transformer, and other technical experts from the utility. Let's say your solar system is producing more power than your home needs during the outage, so it pushes the excess electricity into the utility grid. Any utility technician working on the electrical infrastructure in the area could be seriously hurt or worse, killed. Therefore, the regulatory environment does not allow solar systems to function during a power outage, and manufacturers have to fulfill certain technical requirements to make sure they comply. So what's the solution? The answer is your own microgrid. In layman's terms, a microgrid is functionality that allows your solar system to operate off-grid. To create your own microgrid, conceptually you'll need your solar system, a switch, and a battery system. The switch disconnects or islands your home from the utility grid. In other words, it creates an island in which you can produce and use your own power. This type of switch is also often referred to as a backup switch. The battery becomes the new grid for your home. Because your solar system needs the grid or a grid, it can continue to operate when your battery system takes over the grid function. Let's look at what actually happens when the grid goes down. You have your home with the solar array, the grid, and now you're connected to the grid with a switch, the backup switch. You also have a battery system installed. Now, when the grid goes down, the backup switch automatically opens, thereby disconnecting your home from the utility grid. Your battery immediately becomes the new grid. Now you're fulfilling the requirements for a microgrid. Your solar can now operate, your battery system is providing backup, and your switch is keeping any utility worker safe. You are now, for all practical purposes, an island. Self-sufficient, producing, storing, and using your own power, and not relying on the grid to always be there. That's a pretty exciting feeling. With SIG Energy, the anatomy of your energy independence consists of the following major components. First, of course, you have your solar array. Second, the SIGEN controller. Think of the controller as the brains of the operation. It controls the operation of the entire SIGEN-Store solution. The controller also has the function of converting DC electricity into usable AC electricity and vice versa. Then you have SIGEN battery packs. And just like Legos, you have full flexibility to size the system to your particular needs, no matter what your power requirements are. An optional module is our V2X module. This is the bidirectional DC EV charger with which you can charge and discharge your EV. Discharging your EV in most cases means that you can back up your home in a power outage with the battery power in your EV. Again, this is an optional module that you can decide to add at any time. Lastly, the load hub. This includes the backup switch we've been talking about to island your home from the grid. The load hub is a multifunctional device to add features and value to you as the homeowner. Aside from being the backup switch, It also includes load management, which I'll talk about a bit later, and generator integration. If you have a standby generator at home, it can be connected into the load hub, and the load hub can turn it on and off automatically based on whether your batteries need to recharge. There are actually two options for backup switch functionality. The first is the load hub, as discussed, with load management and generator integration included. The second is a meter collar solution. It provides the backup switch only, which is housed in a device that fits neatly between your electricity meter and its housing. The installation is easier and cheaper compared to the load hub, but you don't get load management or generator integration. So it's really up to you as the homeowner which backup switch option you would like to choose. The load hub is a more expensive solution, but it provides more functionality and a better user experience, especially during a power outage. The meter collar is a less expensive solution without as much functionality. Now, let's walk through a real-world power outage to see how your system might behave. You now have a Solar&Solar solution installed at your house to manage your power. The sun comes up and makes its way through the morning, passes the noon hour, and all of a sudden at 2 p.m. the power goes out. Since you have a backup switch installed, it immediately opens. The battery system becomes the new grid, and your solar system continues to operate. You are now off the grid, producing, storing, and using your own power. Let's assume your battery is full, and as we go through the rest of the afternoon, your home needs electricity that both your solar and your battery provide. Your battery partially drains throughout the afternoon, and now the sun sets. Your solar, of course, stops producing, and you are now relying solely on what is left in the battery. During the evening and night, your battery drains even more. However, it drains slower because you usually don't use very much power once everyone settles down for the night. Remember that you are only relying on your battery at this point. The grid is still not back, and your solar is not producing. Later, you arrive at sunrise of the next day. Your solar starts to produce electricity, and during the course of the day, it runs your electrical loads and recharges the battery. It may not be able to charge the battery to 100%, depending on your electricity usage. You arrive again at sunset, and your solar has stopped producing. The battery will carry you through the night until the sun rises and the whole cycle starts all over again. With this kind of setup, you could ride through a power outage indefinitely, leapfrogging through the night to wait for the sun to recharge the batteries and service the home loads the next day. This is how it's supposed to work. So what can go wrong? Going through the first day as before, the power outage starts at 2 p.m. Grid goes down, the backup switch opens and islands your home from the grid. Your battery becomes the grid, and together with the solar, it makes you self-sufficient. However, as you go through the afternoon and early evening, the battery could drain faster than anticipated, leaving you with an empty battery even before the sun goes down. What now? Now you have a solar and battery system that is not backing you up. You're once again living an off-grid situation without power. This often happens when you're running what we call power-hungry comfort loads, when the grid outage occurs. These include air conditioning, your pool pump, maybe an electric dryer. Today's batteries are powerful enough to take these heavy loads over when the grid fails. Often you as the homeowner don't even notice that a power outage has occurred because the system takes over right away. And because you have a limited amount of power in your battery, running these loads can quickly drain it to completely empty, setting you up for a bad evening and nighttime experience. What's the answer? Going back to our backup switch options. Remember that the load hub has load management functionality, but the meter collar does not? Load management or load control can dramatically improve your experience during an outage. In layman's terms, here's how load management works. Power-hungry loads are loads or appliances that need comparably a lot of power. These may include your air conditioning, your pool pump, an electric dryer, a hot tub, etc. We also call these comfort loads. You don't need them to survive. They're nice to have to make you comfortable and maintain a certain lifestyle. Well, in a power outage, what's the most important are your essential loads. These are typically lower power loads and appliances, but they're much more important than the comfort loads when you have limited power available, like in a power outage. For example, Lights are essential at night, not only to be able to see what you're doing, but also to keep you and your family sane, safe, and functioning. Prolonged power outage is no joke. It can be very stressful and scary. Other essential loads include your electrical outlets, so you can charge your phones, laptops, even watch TV if the internet is still on. You can even make your kids some toast in the morning or do some light cooking. Lastly, your food is essential, especially what is currently in your fridge and your freezer in the garage. Losing all your food during a long power outage can cost you hundreds of dollars if your fridge and freezer are full. Load management or load control means that the system can automatically turn off any or all of the comfort loads during a power outage in order to ensure that your battery always has enough power to service what's most important, your essential loads. The goal here is to never lose power to your essential loads, and you can achieve that by turning off these power-hungry comfort loads at the right time. I'll go deeper into the load management topic in another video to explain the functionality in more detail. This is an important consideration in sizing your system and choosing which kind of backup solution you want to buy. Many solar salespeople have improved their knowledge base over the last couple of years and will be helpful consultants in helping you choose the best solution. However, there are many solar salespeople out there who just want to sell you a solar and battery system, and they don't really know how to build or care about what the right setup is for your situation. There are just far too many systems sold and installed as whole home backup that look like this one. I'm not trying to single out a competitor. I'm highlighting the fact that a single battery like this with a meter collar backup switch will almost never meet your expectations for whole home backup during a power outage, because your battery will be empty within an hour or two, depending on what is running in your house at the time the power goes out. Your options are to add more batteries, to solve the problem with load control, or to add a generator. As already mentioned, today's meter collar backup switches do not support load control or a generator. And if you already have this kind of system installed at your house, your only option is to add another battery like this, which can be very expensive. And if you want to do this a couple of years down the road, the current technology may not be backwards compatible. In this case, you cannot even add more battery capacity, and you're stuck with what you installed on day one. With SigEnergy, you don't have to worry, because we give you full flexibility to add battery packs or the V2X module at any time during the life cycle of the system, even 15 years from now. If you start with a load hub and a smaller battery system today, like 2 battery packs, the load hub can perform load management for you during an outage to make sure you always have at least your lights, plugs, and refrigeration. If 3 years down the road you want to add more battery capacity, it's as simple as adding another battery pack within an hour or two. If you then want to add our V2X module 5 years later, because you now have an EV and you want to take advantage of the bidirectional charging, you can easily add it with the help of an installer. By the way, if you start with SigEnergy's meter collar backup switch, you have the same flexibility to add to your system. You just don't have the option for generator support and load management. The last topic I'd like to discuss here is how fast the transition from on-grid to off-grid occurs. When the backup switch opens to island your home from the grid, the switching time can cause an interruption. You may see your lights flicker, your digital clocks, including your oven and microwave clocks, may reset, and your desktop computers may reboot due to this quick interruption of power. These aren't a huge deal. They are minor annoyances in exchange for backup power. However, when it comes to home medical equipment like oxygen machines or other sensitive medical electronics equipment, even very short interruptions may be dangerous or even life-threatening. Unlike any of our competitors, at SigEnergy we've created 2 switching modes. Normal mode has an actual switching time of about 20 milliseconds, which in most cases enables your lights, clocks, and desktop computers to continue without interruption. However, if you want to make sure to have no disruption at all, we have a 0 millisecond disruption mode, which performs an instant transition where even sensitive electronics are not in danger of being disrupted or shut down. Competitive equipment vendors only have a single switching mode, with many at around 20 milliseconds and some up to several seconds. The 0 millisecond transition mode does take a little bit of battery power continuously, so there is a trade-off to an instant transition. Make sure to review some of the other videos that are related to backup power when the grid is down. We will dive more deeply into load management, backup reserve, and black start.